Hi everyone, this is Fahad Mirza and I welcome you to my channel. In this video, we are going to have a look at a very interesting project called as Chonkie. The tone and tenor of this project is quite light and funny, and when you would be going through its repo, you will enjoy reading it, I can assure you. Also, not only it is funny, it strives to do something quite useful, and that is to make the process of chunking in your retrieval augmented generation or RAG process, or even just for providing the information to LLM easier. So what is chunking and why it is important? Let's have a quick look at that, and then we will locally install this chunky, and then we are also going to play it out with some of the examples hands-on. Chunking is a process that enables the LLMs to efficiently and accurately process information. Just think that you want to do the RAG. You have heaps of your company's documents which you want to feed into your vector store or vector database. One way is to just convert them and throw them into your LLM, but the problem is that the context length of even the embedding models or the large language models is not huge. They can only look at specific portion of the text at a time. Still, as we speak in 2024, that is a problem. That is where we need to divide our own data into smaller pieces called as chunks. So what happens is that this enables the LLMs to predict the information accurately, and despite all of these advancements in model architecture like transformer, adding more context still comes at a cost in speed and memory requirements. To mitigate this, chunking breaks down a large amount of information into smaller, more manageable pieces. This ensures that models receive only the most relevant data, reducing noise and confusion. Providing accurate and granular information is vital for optimal model performance, especially when you have less VRAM. When models receive too much irrelevant data, their accuracy suffers. Chunking helps preserve important details by representing complex information in a condensed format. This leads to higher quality outputs from RAG models. Another critical factor in chunking is speed, especially when working with vast datasets or frequently updated information. And if you have worked with a RAG pipeline in a production environment, then you know what I mean. Faster chunking saves human time and enables model to process large scale data very efficiently. As this RAG technology continues to evolve, chunking will likely remain an essential component, making it important to prioritize its development and optimization. So now you know what exactly this chunking is. Now let's have a look at what this Chonkie is. So Chonkie is trying to make this whole process of chunking easier and faster. Whenever you are converting your own data, or you are pre-processing or preparing your data for RAG, you have to distribute it either by token, word by word, sentence by sentence. Sometimes there is a lot of overlap, sometimes there is a blotting, sometimes it is quite slow, and then you have to worry about dependencies, speeds, and few other factors. That is where Chunky tries to help out, where it enables you to install and import one package, and then with that one package you can chunk your data as per your own use case, also in a quite a speedier way. They say that it's a no nonsense RAG chunking library. So that is what Chonky is, and that is the purpose of Chonky, to chunk your text or data in a faster, speedier, easier way. So before I get it installed, let me introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, it is resilient, it is reusable, and it structures the output according to the shape of your query, and I will drop the link to their website in video's description. Let me take you to my terminal where I'm running Ubuntu 22.04. Let me first create a virtual environment with Conda, and we are going to install our Chonkie in that virtual environment. So let's wait for it to get created. Okay, so that is it installed. Let's now install Chonky with simple pip command, and I am installing all the dependencies. You can, if you already know that, you just need to do sentence chunking, which means that you just want to divide your documents into sentence or words. You can only download that piece of the software, but I'm installing all of it. So let's wait. And Chonky is installed, and this takes around a minute or so. Let me launch my Jupyter notebook so that we could play around with it in a notebook browser environment. And the Jupyter notebook is launched. Let me now show you this Chonky is in action. So you see, all we are doing here is we are importing the Chonky from the token chunker. And if you don't know what token is the smallest unit of text that a model can process. Tokens can be words, subwords, characters, or symbols, sentences. And there are different types of tokenizers which you can find on the web. So I'm just going to go with the GP2, but if you like, you can go with something like tick token, auto tick tokenizer, auto tokenizer, and there are various other. And then I have initialized this chunker. After that, I have just given it this piece of text which I want to chunk or divide it into smaller pieces, and I want to just do it on the basis of tokens. So this is where chunker is doing the chunking. This is the chunker which we have defined or initialized or instantiated. And then after the chunker is done, we are displaying the text and the token counts. So this is how easy it is to do the chunking with the help of this Chonky. So let me run this. And there you go. So it has shown us our chunk. And then it has given us that there are 85 tokens. Another cool thing is that you can customize this chunking. You don't want to go with the default size of the chunk. You can change it by simply running something like this, where you can define the chunk size while you are instantiating that token chunker. You can also define what should be the overlap in the text. So let me make this text a bit bigger. So I have increased the amount of text, and then I have also changed the chunk size to 55 and chunk overlap 30. And you can see that now once I run it, it has gone accordingly. So these are the 55, and then it has chunked it very nicely in a very speedy way. So not only you can do the token chunking, you can do the word chunking, something like this. As you can see that now I am using word chunker here with auto tick tokenizer. It is quite fast, by the way. So once you run it, it is going to fetch this auto tick tokenizer first time, and then this is our chunking. So not only you can do that, but also all you need to do is to change this line for sentence chunker, and then it is going to do the sentence chunking. So let me run it. There you go. So it has done the sentence chunking here. And the reason why it is so fast, it also is quite interesting. The reason being is that by default it is using tick token, and tick token is around 3 to 6 times faster than its counterparts, and it is really fast when used with multiple threads. Also, it pre-computes and caches because they never tokenize or embed on the fly. As long as something can be pre-computed and cached, they do that. Store it and reuse it wherever possible. Also, most semantic chunkers re-embed the chunks every time they get updated, but this tool doesn't do that. This tool pre-computes embedding for the sentences and use the mathematical trickery to instead have a running mean pool of tokens. So quite a nifty tool behind the scene, which is quite interesting. And but the crux of the matter is that chunking has become really easier with Chonky. So I will drop the link to it in video's description. Play around with it. Let me know what do you think about this tool. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.